Okay, so now we will proceed to renal function and tests. So this is the second to the last of my topic. So laban guys. Okay, so renal function and tests. So of course, what comes to your mind if you hear renal? Okay, so kidneys. Okay, our kidney. Atong mga kidneys. So our kidneys, it is a paired bean-shaped organs. These are sorry. So these are your paired bean-shaped organs located retroperitoneally on the either side of the spinal column. So when you say retroperitoneally, so retro meaning luyo, peritoneal meaning peritoneum na to, so diri na sa ato ang abdomen. Okay? And then sa isig kakilid sa atong spinal column. So when you yung gamiton inyo hang kamot, no, di lang ka video sa self pero using your hand, i-touch niyo inyong back, okay? Touch niyo yung back. Kaning i-feel niyo inyong ribs, okay? I-feel niyo inyong hanga ribs, ay di niyo ma-feel di ay kinatabunan man ni siya sa imong floating ribs. Pero dapit sa kaning sa may last part sa inyong rib cage, nara dira dapit yung kidneys ha. So kung sakit dira yung kuan basin na ano may charat. Okay, so kana dira nakabutay yung kidneys. So our kidneys have two regions. Okay? So it has cortex and medulla. So there is atong picture. Okay? So nadira. Cortex is of course kani sa gawas sa ato. Kita tao. Here. Okay, so cortex to the color, sa na color. Red nasa. Okay, dara. Cortex meaning sa gawas. Okay? Kaya dali, line ng dali. Cortex, ano yung cortex? Okay? Meron siyang cortex dapit. Okay? And then, ang medulla, okay? So, dili lang, wala lang naka-label diri. Pero ang medulla is, diri na dapit ka ni. Alay lang ang color. Yellow. So, diri na ang medulla dapit, ha? Okay, sulod na siya. Okay? So, kanina, dara. Renal medulla. Renal medulla. Diri na siya. So, kani is cortex. So, diri na siya sa may gawas. Kani cortex ni diri. Then, medulla, diri dapit. Okay? Kana. Erase. Okay. So, our kidneys has what we call the functional unit. Okay? Functional and anatomical unit, which is your nephron. Okay, so nephrons, these are your functional units of each kidney, and it has 5 basic parts. We have glomerulus, your proximal convoluted tubule, your loop of Henle. Loop of Henle kay naay duha. So loop of Henle na ay nakay descending, isa descending panaog, and your ascending loop of Henle. LOH. Okay. So, kana. And we also have your DCT, or your distal convoluted tubule, and your collecting ducts. So, mani ang 5 basic parts ay mga nephrons. Okay. Did you know? So, natay trivia, charot. So, kay balong guro mo, basahan mo ani. So, each kidney, approximately na ay mga 1 to 1.5 million of functional units called nephrons. So, each kidney na ay 1 to 1.5 million nga nephrons. Okay? So, also, our kidneys na ay 2 types of nephrons. So, it could be cortical nephrons or your juxtamedullary nephrons. Your cortical nephrons, so these comprise or makes up approximately 85% of the total nephrons per kidney. So, asa man ni makita sa cortical, no? The word cortical, meaning na siya sa cortex. Nara siya dito sa may babaw. Okay? And ang iyang primary function, no, sa imong cortical nephron is to remove waste products and reabsorb nutrients. So, kasagaran sa cortical, yung function yun is to remove and reabsorb. Remove waste, reabsorb nutrients. What about juxtamedullary nephrons? Okay? So, kung 85% kay cortical, so around 15% juxtamedullary nephrons. So, the word juxtamedullary meaning abot siya sa medulla. Okay? Abot siya sa renal medulla. Okay, so they have longer loops of Henle and they extend deep into the medulla of the kidney, and their primary function is to concentrate the urine. Kung si cortical can remove waste, reabsorb nutrients, si juxtamedullary is to concentrate the urine. Okay, mao na siya. Okay. So, generally, what are the functions of our kidneys? So, primary function, the primary goal of our kidneys is to eliminate waste products. So, kay mao man yung primary goal, di ba? Tanawa, cortical nephrons, sila ang pinakadaghan. Kaya sa ilang primary function sa cortical nephrons, to remove waste products. Kaya mao man po ang primary goal sa kidneys yun, to eliminate waste products. So, aside from that, our kidneys also maintains our blood volume via our RAAS. Also, it maintains electrolyte balance in our DCT, okay, and also in our PCT. Maintains acid-base balance, okay, atong blood pH ni ha. So, pila siya. And also, napod siya endocrine function because our kidneys secretes erythropoietin. So, this erythropoietin, it is a hormone. Okay? So, this is a hormone. Kinundong pa mo. Hormone that, sa man eh, so may purpose aning erythropoietin. Okay? It stimulates our bone marrow to sa man, to perform did to perform erythropoiesis. Okay? Sakto ba spelling? Basta erythropoiesis. Okay? Para especially if kanang anemic mo, so dungagan ang trabaho sa iyong kidneys. Okay? So, kana, si kidney na, erythropoietin. Okay? Okay. So, kana. So, kani, this is a picture from your Stressinger. So, this is a type of nephron. So, diba, ganina, ingon ko ninyo, na ay 5 basic parts sa inyong nephron. So, you have your glomerulus. So, kani, glomerulus. So, glomerulus, kani mo, nilulog ka tanan. And also, you have your proximal convoluted tubule. So, kani, starting the proximal. And then, you also have your thick descending. Kani, descending lobe of Henle na ay thick na ay thin. So, very, so good. Descending. Yanapod tayo thick and thin ascending. So, kani. Okay? Wait pa na, Andre. And then, we also have your distal convoluted tubule. Andre, distal convoluted. And then, we have your collecting ducts. Andre, collecting ducts. Okay? So, na siya. So, natay glomerulus, natay PCT, natay lobe of Henle, ascending and descending and ascending, PCT, and then collecting ducts. Okay? So, na itong nephrons. Okay? Delete. Okay. So, what happens? Okay, so, anito sa next na picture. Okay. So, kani, another diagram of our nephron. So, mas siya, mas 2D siya, 2D. Mas siya ka ng sinauna nga picture. Okay, so, kani, we have the glomerulus here. Color. So, of course, there we have the glomerulus. Okay, and of course, we have the proximal tubule. Na segments 1, 2, and 3. And then, si descending na dayon. Okay? Si descending lobe of Henle, and then si ascending lobe of Henle, and then si distal tubule, and then collecting ducts na dayon. Okay? Then, mana din na? Urine na din na. Okay? Okay. So, mana siya. So, another picture na siya. Ilista na to. Okay. So, kani. So, before we proceed to the different parts, like dig deep ta sa different parts of our nephron and its functions and tests. So, let us go through for a while the renal blood flow. So, our kidneys receive approximately 25%, okay, of the blood pumped through the heart at all times. Okay? So, atong kidney di ay kay the kidneys continuously form urine as an ultrafiltrate of plasma. Okay? Again, our kidneys continuously, meaning padayon na siya, hunong-hunong, continuously form urine as an ultrafiltrate of our plasma. And 25% of the blood pumped through the heart na ana moagi sa kidneys at all times. Kada segundo, kada millisecond, 25% of the blood pumped by your heart na sa kidney. Okay? And for a normal body size, okay, that is 1.73 meter squared, which is, by the way, dili na day ni mao ang average size sa tawo. Okay? So sa una, ang average nga kilogram sa tao is 70 kilograms. But today, kay tungod sa sedentary lifestyle ni human being, nahimo na siya mga 80 kapin. Okay? Sige lang. So, gamitin lang ni nato average body size kay 1.73 meters squared. So, if mo na itong basihan, the total renal blood flow is approximately 1,200 milliliters per minute. Okay? So, total blood flow lang, blood yun, 1 to. If total renal plasma flow, ang range niya is around 600 to 700 milliliters per minute. Okay? So, around 120 ml is normally filtered through the glomeruli. Okay? Renal plasma flow. Sa glomeruli lang, mga 120 ml per minute mo nang gina-filter. And the rest kay adyo sa PCT, sa DCT, Henley, collecting ducts. Okay? Muna siya. And also, para mahitabo ning 1,200 milliliters per minute nga total renal blood flow, so around 170 ml of filtered plasma ang gina-filter sa kidney per day para makaproduce siya og 1 to ml per minute nga renal blood flow. Muna siya. Okay. So, muna ang renal blood flow. So, first is ito tawag. Okay. So, first we have the renal artery. Okay. Okay. Asa man to? Okay. So, kani naatay dara. So, we have the renal artery. So, mo ni ang supply of blood sa ato nga kidneys. Okay? Diri gikan ang dugo. Ito ni color red, red. So, diri gikan ang dugo. So, renal artery, and then renal artery moagi kang afferent arteriole. Okay? So, agi ni afferent arteriole. Okay? Agi siya diri ang dugo. And then, here in our glomerulus, naatay mga glomerular capillaries. Okay? Kanimo nag-glomerular capillaries. Magkuha na sila, mag-intertwine na sila. So, later, makita nato unya. Okay? Ang katujong kana galing kuan gyud kanang specific nga mga parts sa ato ang glomerulus later. So here na glomerular capillaries magi ang dugo, and then it will be filtered. Okay, it will be filtered. And then maagi sila sa proximal tubule. Okay, so uban kay to gani i-reabsorb balik. So also di ay before ta mo padayon ani. So katong di ba 25% naman na diri. Diba? Nga, around 120 ml naman of plasma ang gina-filter sa glomerulus. So some of the blood or plasma manhin na diri sa efferent arteriole. Wala sa diri. Okay? So kani kay kuan ni siya diri ha ng blood vessel ni. Yagi na siya diri. Efferent arteriole mahimong peritubular capillaries kay. Capillaries siya dapit man sa imuhang tubules. Then here in the loop of Henle mahimo siyang vasa recta. Kani nga mga blood vessels. And then mahimo na pud siyang peritubular capillaries kay nana man pud siya dapit sa distal tubule. And then hantod sa mo agi siya sa collecting ducts. Okay? Until nga sulod siya sa renal vein. So mo na ang flow sa blood. So what about if ang blood diri na sa glomerulus and then na-filtered na siya? So ika-filter niya, agi siya sa proximal tubule, sa imong PCT, and then the nutrients nga needed sa body will be reabsorbed. Reabsorb siya and then ibutang diri sa peritubular capillaries. And some of the substances nga wala na filter diri Nya nilahos ra diri sa may peritubular capillaries, isikret na siya para moadto kang proximal tubule. And then flow na sila, flow ning nga ni ultrafiltrate. And then muagi na din sa loop of Henle. Okay? Descending loop of Henle, and then mo-ascend na po siya. Okay? And then diri na po sa distal tubule. So ang katong mga needed nga wala na reabsorb sa proximal tubule, i-reabsorb diri sa DCT. And katong mga wala na secrete pa dong sa proximal tubule, kay diri i-secrete para mo adto kang distal tubule. So waste gyapon. After ana, if na okay na siya, balik na siya sa renal vein. Okay? Okay. So, kani siya is overview lang siya sa renal blood flow. Okay? So, actually, daghan pa og kanang daghan pa ni og details. Okay? But again, we will be able to go through it. Okay? Makuha na nato as we go on our discussion. So, kani overview lang siya. At least, kay balo mo aso siya moagi. Okay? Kasi pasunod niya. Okay? So, ana siya. So, that is for your renal blood flow. And also limot ko. So after there sa distal convoluted tubule, of course manhina siya sa imong collecting ducts. Okay? And then we have the outer medulla of your kidneys. Okay? So unsa pa toy need nga ipagawas, need iadto sa ihi. So iadto na didto until sa mahimo na siya nga urine, excrete na dayon siya. Okay. Okay, so that is for your renal blood flow. So this is just a general overview of your renal blood flow. Okay, so our topic, of course, it will revolve around glomerular filtration. So for glomerular filtration nga function sa imong kidney, so of course we have to study the cellular structure of glomerulus, mo man ang filtering parts imong nephron, the pressure on the glomerulus, and your RAA system. And then after that will be tubular reabsorption mechanisms of our PCT and DCT, tubular concentration, and even your collecting ducts po di concentration. And of course, during tubular secretion, kaning function is to maintain our acid-base balance. Okay, so muna itong go through as we go on our discussion. So first is glomerular filtration. Okay? Glomerular filtration, of course, what part of the nephron ang responsible ani? Of course, it's your it's your glomerulus. So here, your glomerulus, it consists of approximately 8 capillary lobes. Okay? So 8 capillary lobes. So ang pronadri kay 6 ra. Okay? So 1 2 3 4 5 6. But actually approximately round po rin. Approximately 8 na sila ka-capillary lobes, and the walls of these capillaries are referred to as glomerular filtration barrier. Okay? Yes. Okay, so your glomerulus also is contained or located within your Bowman's capsule. Okay, Bowman's capsule. So kanina Moni inyong Bowman's capsule. Okay? Your Bowman's capsule forms the start of the renal tubule or your proximal convoluted tubule. So, again, mga 8 capillary lobes, unya ang walls ana imong capillaries are referred to as glomerular filtration barrier. So, may baon na to na later nga gitawag siya glomerular filtration barrier. And this is your Bowman's capsule that contains your glomerulus. Okay? And it forms the start of your PCT, kaninga part. Na siya. And your glomerulus is a non-selective filter for plasma substances. Basta ang molecular weight niya kay less than 70,000 kilodaltons. Okay? So your glomerulus, non-selective siya for any plasma substances as long as gamay siya. Okay, dapat less than 70,000 kilodaltons, boom, lusot na siya. Okay? Okay. So, your glomerulus, di ba ganina, your capillaries, katong 8 lobes of capillaries, ang walls niya gitawag siya og glomerular filtration barrier. Kaya naman, it has 3 cellular layers that composes the glomerular filtration barrier. First is the capillary wall membrane. So, ang wall gud sa imong capillary. And then the basement membrane of your capillaries. And then the visceral epithelium of your Bowman's capsule. So, first is capillary wall membrane. So, color ani, yellow lang. So, kani yung walls sa imuhang the walls of your capillaries. And the wall of your capillaries, napo din ha imuhang basement membrane. Okay? So the walls, makibaw na to unya, nasa capillary wall, nasa basement membrane. Okay? And aside from that, the visceral epithelium of our Bowman's capsule. So, visceral meaning kani, sulod. So, unsa may epithelium nga naa sa ato ang Bowman's capsule. Visceral epithelium of our Bowman's capsule. This is your squamous epithelium. Okay? So, kanina nakahatag po siya og additional nga barrier, no, para dili pataka o filter po dato ang kidneys. So, what are these glomerular filtration barrier layers? First, capillaries wall of your of course, the wall membrane of your capillaries. Then the basement membrane of the capillaries, and then the visceral epithelium, squamous epithelium of your Bowman's capsule. Okay. So kani, muna gingon ninyo, this highlight or this shows us the details of your glomerulus. Okay? So mas kuani siya. So di ba ganina ingon ko ninyo ano nindot green. Nakay na. Okay. So, from our butang na to, renal artery ni. So, ang blood na to moagi diri sa afferent arteriole, and then diri na siya sa atong 8 lobes of capillaries, approximately 8 lobes of capillaries. Na diri ang dugo, moagi diri ang dugo niya. Some of the blood nga dili ma-filter diri ani sa afferent arteriole. Okay? So, here in our afferent arteriole, okay? So, natin gitawag nga hydrostatic pressure. Natin duha ka pressure nga makita dinhi. Okay? Pero later lang na, ato sang kuan ang anatomy. Okay? So, the blood goes from the renal artery, goes through the afferent arteriole, and then it goes through our 8 lobes, approximately 8 lobes of capillaries in our diri gihouse sa ato ang Bowman's capsule. So, so diri so kani mo natin ang Bowman's space na siya. So kani siya hole is our Bowman's capsule ha. And then giline niya diri ato ang capillaries man ang Bowman's capsule. So pero ako i-reason kay matabunan ang uban nga parts. Okay. So when the blood goes through diri sa ato ang capillaries, okay? So, on our capillaries, naatay duha ka buok nga filtration barrier, di ba? Naatay katong walls of our capillaries and the glomerular basement membrane of our capillaries. So, kasi din naa sa walls ato ang capillaries. So, natay gitawag nga fenestrated epithelium. Okay? So, the epithelium of our capillaries is fenestrated. When you say fenestrated, meaning buslot. Okay? Darao, nadiri. Mas closer, mas dako siya. So, buslot siya. Nasa mga lungag-lungag. Also, on our capillaries, we have the glomerular basement membrane. Okay? Nga, usap pod siya sa tabang nga dili pataka og filter ang kidneys. Okay? So, naay additional nga barrier is buslot ang epithelium sa ato ang capillaries atong glomerulus kay naagihapoy ali, which is our glomerular basement membrane. Okay? And then also, we also have foot processes of our podocytes. Okay? Podocytes also, nagkuan gihapon ni. It also contributes to the barrier. Okay? Podocytes na to, podocyte. Foot processes, kaning gagmay. Okay? And of course, your proximal convoluted tubule. So if we if atong i-zoom no ang ato ang a certain part of our glomerulus no dire so mo ni ato ang for example kani sulod is mo ni ang ato ang sulod sa atong capillaries. So mo ni atong mga blood, okay, red blood cells, proteins and then if makita ninyo, di ba, usa sa glomerular filtration barrier is the epithelium or the walls of our capillaries. So the walls of our capillaries, naapod na siya lining epithelium, which is your squamous epithelial cell. Okay? But then naa siya slits, naa siya kanang mga buslot, fenestrated ang epithelium. So though yes, epithelium maka-barrier siya, but naman siya slit, so makalusot gihapon. Diba, ingon ganina, non-selective ang filter sa imuhang glomerulus, basta kay less than 70,000 kilodaltons makalusot lang. Kaya nga naman, naaman siya fenestrated epithelium. Though, dili tanan makalusot. Okay, gagmay man po ni nga mga buslot. So, mga 70,000 below ra gyud. Okay, molecular weight. So, aside from that, the presence also of your glomerular basement membrane. Yung glomerular basement membrane, wala yun ni siya buslot. Okay? And only those substances nga makalusot are those substances nga pwede ma-carry through active or passive transports. Ano siya. So, we will discuss also about that later. And then, aside from that, okay, na-fenestrated epithelium, na-glomerular basement membrane, and of course, third is your podocyte foot processes. So, naapod na yung mga, napapadyo ka ng mga, tiil-tiil sa imong podocyte. Nga, naka-dugang nga dili makalusot-lusot yun. Doon na ay makalusot pero dili yun pataka og lusot. So, again, ang criteria is katulang yun less than 70,000 kilodaltons. And also, aside from that also, I would like to emphasize that aside from less than 70,000 kilodaltons nga molecular weight of substances lang ang makaplusot, negatively charged substances are also not permitted to pass through. Okay? Kaya nga naman, your kanimong tulo, okay, particularly here in your glomerular basement membrane, okay, so naa ni siya naa siya component or composition sa imong glomerular basement membrane nga nakakos og negative charge ani nga surface kani nga particular part sa imong glomerulus. So naay certain substance that composes your glomerular basement membrane nga makakos og negative charge or negatively charged siya nga substance, and kana nga negative charge nga surface or area causes the negatively charged substances like your proteins ma-repel siya o dili siya ma-filter sa imong mga kidneys. Okay? Ana siya. So again, aside from the anatomy, okay, na kay fenestrated epithelium, naka epithelium, pero kay na siya buslot, so makalusot ang mga gagmay, naka glomerular basement membrane, nakatulang mga substances nga ma-carry through active transport and passive transport ang makalusot, and negatively charged substance di jud kalusot tungod kay naay certain substance that composes your glomerular basement membrane nga nakakos nga naay negatively charged sa kani nga area sa imong glomerulus. And also podocyte foot processes nga nakaali, although naapoy slits, pero it only allows those gagmay, okay, and not negatively charged nga mga substances. Okay? For example, protein. Pwede dapat makalusot si protein. Okay? Na siya. Okay. So, this is for your glomerular filtration. So, di ba ganina nag-ingon ko ninyo nga na ito ka pressure nga itong makita din here. We have the hydrostatic pressure and the oncotic pressure. So, hydrostatic pressure, one of the Starling, and oncotic pressure are one of the Starling forces. Okay? Hydrostatic pressure, it is a pressure nga it is the pressure nga gi-apply, na pressure applied where your fluids, no? Fluids are pushed para mugawas. Okay? And oncotic pressure on the other hand is a pressure that keeps the fluids, keeps the substances nga magpabilin sulod sa imuhang vessel. Okay? Mo na siya. So again, there are two forces. Hydrostatic pressure meaning ang gusto ni nga pressure is ipagawas ang any fluid or substances. And another opposing of pressure known as your oncotic pressure is ang gusto niya is ipabilin sa sulod ang mga ang fluid or any substances. So, ang mahitabuan ni here on our afferent arteriole, di ba? Blood, agi din sorry. So, agi diri ang blood. Okay? So, ang himo ni hydrostatic pressure diri, ganahan niya ipagawas yun. No? Dapat mo gawas si blood. Kaya kung wala hydrostatic pressure, wala ma-filter nga dugo, di ba? Wala ma-filter nga mga waste. So, dapat na ay pressure nga mo push good nga mo gawas sila. But, of course, amazing kang kidney, na ay lain nga pressure nga mo counter to make sure nga dili ma-filter ang katong mga important nga mga substances as much as possible. So, one of these substances nga gi-prevent sa oncotic pressure nga ma-filter is our proteins. So, also, our plasma proteins, siya pod ang mo carry out ani nga pressure, particularly your albumin. Si albumin, siya nam siya colloidal property. So, siya ang responsible nga ma-maintain ang oncotic pressure diri sa imong glomerulus. Ma-make sure niya nga dili tanan mo gawas. Ay kung puro sa hydrostatic pressure, okay, gawas tanan. Okay? But naaman si oncotic pressure nga nag-regulate kang hydrostatic pressure nga oops, dili pwede tanan mo gawas. Okay? So dapat controlled lang. So naay uban pwede ning uban dili. Okay? So importante ni siya kay nganuman here on our next slide. So, glomerular pressures, these are important because if naay mga problems sa ato ang blood pressure, blood volume, so these pressures also changes. And kung ato ang hinumduman ganina, okay? So, our kidneys, di ba, it receives at all times 25% of the total cardiac output. Okay? 25%. So, dapat yun na, maintain yun na nga percent. Okay? And around 120 ml of plasma, di ba, gina-filter sa atong glomerulus. So, ang ato ang kidney, wala siya'y, or this said wala, marag kanang, dili niya kaya nga kanang kuwang ang blood nga moagi sa iyaha. It is very important nga katong 25% should be maintained at all times. Dapat yun na. Okay? Because if mo lower na, pwede man mo lead to hypoxia. Okay? Mag-hypoxic ang imong nga kidneys, daot imong kidney. Okay? So what amazing lang sa atong kidney kay naa siyay system iyaha to make sure nga bahalag mag-fluctuate ato ang blood pressure, atong blood volume, dili madaot si kidney. Okay? So kani, one of this pressure is your hydrostatic pressure. So what will this hydrostatic pressure do? So the presence of your hydrostatic pressure results to the smaller size of your efferent arterioles, and the glomerular capillaries enhances filtration. So, may pasabot ani, di ba? Okay. Okay. This is your afferent arteriole, di ba? Diri kay renal artery. nya si dugo mo ni kang afferent arteriole. Okay? Hydrostatic pressure is applied here kaya naman gusto man nato or gusto sa kidney nga ma-filter ang dugo. Okay? So, ang buhaton ni hydrostatic pressure iyan ni ipadako. Okay? Pa-increase niya okay, ang size sa imong afferent unya ipa-decrease niya ang size sa imong efferent. Kaya naman, ang gusto mo sa kidney is dapat daghan ang dugo para 25% maka-flow, di ba? But making sure pod nga gamay dapat ang efferent arteriole kaya nga naman. Kay kung imong idako og maayo, dili makatarong og filter si glomerulus. Okay? Ditso na din sa efferent. Okay? So if dako kaayo diri sa efferent, imong 25% balik ditso ra po na din. So your hydrostatic pressure ensures that the afferent arteriole size is big but the efferent arteriole size is small. Kay para ang pressure, taas ang pressure diri. Okay? Kaya para ma-filter gyud sa mga dapat ma-filter. Unya, dili mo anhi dinhi nga paspas kaayo nya wala na tarong filter diri. Okay? So mo na ang purpose sa imuhang tagani hydrostatic pressure. Okay? And it is necessary to also overcome kay ang imuhang Bowman's capsule diri, Bowman's capsule nimo. Napud siya iyang nga pressure. Okay? So ang pressure nga natin is your oncotic pressures. Ang gusto ni oncotic pressure kay dapat naarabya niya, dili pwede mo gawas. Especially kani mga plasma proteins, kani man gyud ni ang nag-cause og oncotic pressure. So ganahan sila nga naara sa sulod, pero dapat man gyud ma-filter. So hydrostatic pressure ensures nga kung unsay dapat mo gawas gyud. Okay? But of course, oncotic pressure on the other hand counterbalances. Dili pod patakag paggawas. Okay? Ay mong glomerulus. Okay? So what will happen? Okay? Ang ato ang kidneys as what I've told you kanang amazing kay siya kay although dili niya kaya nga makuwangan ang blood supply sa iya but naa siya system nga ginagamit. So aside from hydrostatic pressure, kung makita ninyo dinhi natay macula densa. Okay? Natay macula densa and then ubos niya na ay juxtaglomerular cells. Si macula densa is dapit ni distal tubule. Okay? Nya, ubos ni macula densa is your juxtaglomerular cells. So, ang ato ang blood pressure and blood volume mo fluctuate man yun na. Okay? Mo fluctuate yun na siya. So, what will happen? Di na nato man kayan. Okay? Isang galing position lang nato. Example ka. Hindi ka kalikag barog. Ubos man na imong blood pressure. So, di na ito malikayan. And dili na kaya sa kidney nga every time mag-inana, ay makuwangan siya og blood supply. So, dapat ma-maintain yun na niya. So, mo ni ang system. So, mahitabuan na, okay, your afferent arteriole and efferent arteriole plays also the role ani. Okay? So, ang hitabuan ni is, for example, na ay low blood pressure. So, low blood pressure, gamay ra ang flow sa blood, pressure sa blood. So, ang buhato ni afferent arteriole is mugamay siya. Okay? So, sa to, if low, dapat dili ka yung color. Okay. So, if low blood pressure, okay, low ang BP, ang buhato ni afferent arteriole kay, si afferent arteriole, kay mo, constrict siya. Mugamay ang size. Okay? And si efferent arteriole sayo if low sayo mo din naglibog ko. Okay, again, if constrict if low imong blood pressure, if low imong blood pressure kay gamay ra man ang flow sa blood ana, kay gamay ra man ang pressure ng push the blood pa doon sa kidneys. So si afferent arteriole kay increase niya iyang size para mas daghang dugo ang maka-flow. Kay again, 25% should be nasa kidneys. Okay? Na dapat 120 ml gina-filter gyud sa imuhang Bowman's cap as imuhang glomerulus per minute. So if low blood pressure, si afferent arteriole will increase its size and si efferent arteriole will decrease its size. Same ni sa katong gingon ako ganina. So normally ana na siya to maintain gyud the 25%. But if mag low blood pressure kay samot mo open si afferent, nya mo constrict samot si efferent to make sure nga the correct, the enough amount of blood is naka-flow gyud diri sa glomerulus and ma-filter gyud siya. In cases of high blood pressure, so kusog kay ang sa dugo, no? Sug sa dugo. So the afferent arteriole will decrease its size, or it will constrict. Okay? It will constrict its size, and then your efferent arteriole will increase its size. So di man pud pwede nga daghan po yung dugo, so lumos po di mo nga kuan kidneys, this is not pwede. So again 25%. Okay, so if taas kay ang pressure sa dugo, mo constrict si afferent para daghan na kaayo, so pagamay ta para gamay ra makasud kay 25% ra pwede, and then your efferent arteriole will open para maka lusot ra gyud tong mga dugo nga nanod kay daghan makaayo. So inanaha, take note of that. If low blood pressure, sa himuon sa afferent o efferent, if high, sa himuon nila. Okay? So inana na siya. Okay. So aside from that, okay, aside from your afferent and efferent arteriole, okay, nga mo constrict o mo dilate during fluctuations of blood pressure, okay, you also have your RAA system, or your renin-angiotensin-aldosterone system. So mas long-term ni siya nga effect para ma-correct ang fluctuation of pressure or volume sa ato ang blood. So also this system mo po ni ang responsible para mo dilate or mo constrict imuhang afferent and efferent. So common ni siya if na ay low, okay, low nga blood pressure or volume. Okay, so ang mahitabuan ni is it dilates your afferent and it constricts your afferent, and then it stimulates the reabsorption of your sodium. Again, low blood pressure, low blood volume, so where the salt is, water will follow. So dapat mabalik sodium kay para ang tubig po mo balik sa body. Okay, it stimulates sodium reabsorption in your PCT, and it triggers your adrenal cortex to release sodium retaining hormone, your aldosterone. Maibaw na nato niya unsaon na siya. Okay, so your aldosterone will cause reabsorption of sodium and excretion of potassium in the DCT and collecting ducts, and also it triggers your antidiuretic hormone to be released by the hypothalamus to stimulate water reabsorption in the collecting ducts. So ma-release si aldosterone, ma-trigger po si ADH para si water po ma-reabsorb. Ma-reabsorb sodium, ma-reabsorb po si water. Okay, low pressure and low blood volume man. So mo ni ang may tabo. Okay. So di ba naatay ko Andre? Okay. So diri naatay glomerulus. Okay? So for example, naay low blood pressure, naay low plasma sodium, uban low blood volume, uban. Okay? Low blood volume. Okay? So if na siya, again, dili kaya sa kidney nga, pero may siya kuan ana. So dapat ma-maintain yun ang blood supply. So ang may tabo is the fluctuations of the pressure, okay? The low plasma sodium, low blood volume will be detected by your macula densa. Ganun sa color. Cha. Kanin kira. Will be tubo na. So this will be detected by your macula densa. Mao bitaw nga si macula densa, although dapit siya sa distal tubule, pero nasa diri dapit tunga sa imong afferent o efferent arteriole. Okay? Ma-detect man niya ang pressure good. So if na ay fluctuations of pressure, especially if na low blood pressure o low plasma sodium, ma-detect na niya. Si macula densa, yay, kamay raman ang blood pressure. Kuyawan ni. Okay? Pwede magka-hypoxia ang kidney. So iha dayon na isignalan si juxtaglomerular. Mao siya juxta, mag need imuhang kuan karon kanang service karon. So juxtaglomerular pag-release og renin. Okay, so si juxtaglomerular after niya maka-receive og signal from macula densa nga uy na low blood pressure, si juxtaglomerular cells will release renin. Okay, so by juxtaglomerular cells. Juxta GCs. Okay? And then your renin, okay? If ma-release na si renin, okay? Your angiotensinogen, okay? So by the action of your renin is a hormone. Okay. And then it's okay, wait, wrong ni. Okay. Your renin is not a hormone, sorry. Balik. Your renin is an enzyme. So your renin is an enzyme, sorry. Your renin is an enzyme. And then, diba, si renin kay gi-secrete ni juxtaglomerular cells. And it is an enzyme produced by or released by your juxtaglomerular cells. And then, as it travels, okay, kay on the vessel, angiotensinogen, which is a glycoprotein, okay, angiotensinogen, which is a glycoprotein, serves as the substrate of your renin. So mag-usa ni sila, mag-combine na sila din okay, renin, and your renin, the enzyme renin, will be converted to enzyme via the substrate angiotensinogen. This is a glycoprotein. Okay, so your angiotensin. So renin, which is an enzyme, it combines or it reacts with your substrate angiotensinogen, which is found on the bloodstream, produced by your kidneys, liver, epithelial cell. So i-react na niya, your renin will be converted to angiotensin 1. Okay, angiotensin 1. And then your angiotensin 1 will react with your ACE, your angiotensin converting enzyme, okay, so that your angiotensin 1 will be converted to angiotensin 2, which is the active form. Okay, so your angiotensin 1 is not active, well, your angiotensin 2 is the active form. So your angiotensin, okay, so your angiotensin is a hormone, okay, so si renin is enzyme. Si angiotensin okay, so again, your renin is an enzyme, and then it reacts with your substrate angiotensinogen para mahimo ang imong hormone nga angiotensin. So this is a hormone. So balito ganina So angiotensin 1, so inactive pa man siya. So by the action of your angiotensin converting enzyme, okay, so your angiotensin 1 will be converted to angiotensin 2, which is still a hormone. Okay, so your angiotensin 2 is an active form. So active na siya, and your angiotensin is responsible to the regulating of your blood pressure by, of course, constricting your blood vessels, and diri na mahitabo ang series of different effects. So angiotensin 2 is an active hormone, and its effects is vasoconstriction. So may tabo again, kisa to mo constrict si afferent arteriole. So iya ipa iyang i-constrict si efferent, ano siya naman ko? Si efferent arteriole, iya open si afferent arteriole. But then ang pasabot aning vasoconstriction are those other nga mga vessels nga labi na katong mga dagko nga vessels, ipagamay ito nila para mutaas ang pressure. Kay low pressure man, if padayon mo gud siyang lapad, or ang size sa imuhang vessel kay padayon na siya nga dako, so kanang mo flow ra ang blood pero gamay ra siya. So what the body does is it constricts your vessels para mas taas ang pressure, para mas taas ang pagsug sa imuhang dugo. So ana siya. So your afferent artery will dilate, but your efferent will constrict, and other vessels will also constrict. Okay, so next, your angiotensin 2 will stimulate your proximal convoluted tubule for sodium reabsorption. Okay, so ma-filter man ang sodium. sa imong glomerulus. But then your angiotensin 2 will tell your PCT nga PCT ang kanang mga kuan sodium kay ay napagawas, okay, kanang balik. Okay, and also it also stimulates your adrenal, okay, adrenal cortex, no, the organ na nag-sit above your kidneys, okay, nga labi na sa cortex sa imuhang adrenal cortex, no, to produce your mineralocorticoid, your aldosterone. And this aldosterone is an hormone. Sorry. It's a hormone. It's a mineralocorticoid produced by your adrenal cortex. It will signal also your distal convoluted tubule to reabsorb sodium. Okay? So katong mga dili ma-reabsorb ni proximal convoluted, tawgon si distal. Okay nga. Distal anina din okay? I-reabsorb si sodium. So, dili pwede nga ipagawa siya sa ihi. So, as much as possible, ka-reabsorb siya. And also, aside from your aldosterone, it also triggers your, same sa itong ikuan ganina, it also triggers your ADH. Okay? Your ADH is also known as your vasopressin, arginine, nga hormone, still a hormone. Your ADH is produced in the hypothalamus but stored in your posterior pituitary. Okay? So, your ADH also is triggered and it acts on your collecting duct to reabsorb water. Again, the result is water follows. Okay? So, kana siya. For us, ang goal for us is to regulate the blood pressure para mabalik or mabalik sa homeostasis and maintain ang blood flow sa kidney para dili jeopardize or ma-compromise ang blood flow sa kidney. So again, na low blood pressure, low plasma sodium, ma-detect na ni macula densa. Si macula densa iyang sultihan si juxta pag-release og renin. Renin is an enzyme. And sa blood vessels kanay angiotensinogen, which is a substrate produced by your liver, kidney, even epithelial cells. So mag-combine na silang duha and it will produce angiotensin 1, which is a hormone, and then it must be activated by your angiotensin converting enzyme, and yung angiotensin 1 mahimong angiotensin 2, which is the active form of your hormone that causes vasoconstriction, sodium reabsorption on your proximal convoluted tubule, and it also stimulates your adrenal cortex to produce aldosterone, which is a hormone, which is a mineralocorticoid, and it also signals your distal convoluted tubule to reabsorb sodium, and then also it triggers your ADH to act on the collecting ducts to reabsorb water. Okay, para mabalik ang pressure. Okay, maybe because of the low blood volume ang low blood pressure po. So dapat mabalik yun siya. Okay? Ano siya? So, nakasabot lang mo. Okay. Okay, so glomerular filtration rate. So this is one of the tests performed for glomerular function. So glomerular filtration rate is the best overall indicator of the level of kidney function. So mo ni siya ang overall indicator. Pero makibaw ka nga sa nang level sa kidney function nimo. And also clearance. Clearance is the term used for the removal of unbound, meaning wala naka-bound. Okay? Unbound molecules or substances from blood to urine. So dili pwede ang bound kay nga naman most of the substances that are bound, ang nag-bound sa ilaha are albumin. And of course, proteins are not allowed to pass through. Diba? You shall not pass. Ano pa siya? Ano si Dumbledore. Okay? Charot. So, clearance tests. So, these tests are standard tests used to measure the filtering capacity of our glomeruli. No? So, it measures the rate, no, the glomerular filtration rate of our kidneys. If able ba siya maka-remove or ma-clear niya ang kini nga mga filterable substances from the blood. So what are these substances? So we can use creatinine, inulin, urea, cystatin C, and beta-trace protein. So these are some of the substances used to perform clearance tests. Okay? Okay. And also, at present, okay, Your creatinine, beta-2 microglobulin, kaning beta trace man na siya. Cystatin C, and wala na ako nabutang dito, dire na apod tay possibly your radioisotopes. Possibly your radioisotopes are the primary substances used karon, okay, present clearance test. So kani si urea, X na ni siya, wala na kani siya ginayos, okay, and ana siya. And then also your inulin, I think ano na to later, maragyan na to later. So kana siya. And each procedure, each substance has its own advantage and disadvantages. So and also, please take note nga, every year, okay, for example, if 20 to 30 years old na ka, every year, mo decrease yun ang glomerular filtration rate sa tao about 1 ml per minute per year. Okay? So every year nga matiguang daay ta, muubos og 1 ml per minute per year ato ang GFR. So magka-deteriorate yun atong kidneys. Okay? And kanina question, what is the relationship of the plasma concentration of a substance to its clearance? Okay, so saan ang relationship between the plasma concentration of a particular substance and its clearance? Answer ana is inversely proportional, meaning bali siya. Okay? So, okay, so kana. And next is to ensure that the glomerular filtration is being measured accurately. So, the substances nga ato ang gamiton to analyze must be, okay, dapat mo follow siya ani nga criteria. First is, it should not be reabsorbed nor secreted by the tubules. As much as possible, wala ni gina-secrete or gina-reabsorb sa tubule kay maka-affect man siya sa taganing amount nga na filter. Okay? For example, gire-absorb siya balik. So, ang atong sample ba for GFR is kuan kanang urine, di ba? So, gire-absorb man, so dili na ang total amount ang atong ma-measure. Or kung for example, gi-secrete siya, so na false increase kay nag-secrete man naturally ang tubules anang particular substance. So, as much as possible, the substance that we use is neither reabsorbed nor secreted. And also, it should be stable in the urine. Okay? If ever we perform 24-hour collection period, hindi pwede nga, for example, morning, daghan ang iyahang ma-excrete, pero ining gabi kay mugamay. So, dili siya consistent, dili stable. So, what is possible na stable all throughout. Ever mag 24-hour collection man ta. And not just in the urine, but it should also be its level in the plasma should also be consistent. Okay? Dili po pwede magsipod siya, fluctuate, bati po na siya. And also, it should be available in the body. Mas mayo siya kung available na siya sa body. Dili kay ikuan pa nimo introduce pa nimo sa body ba, asol mo na. And of course, there should be a test, no, availability to analyze the substance. So kung saan pa nimo na for example, 1, 2, 3 na nakuan yun niya na-achieve niya kaninga criteria, pero wala yung available nga testing procedure para niya. So, marang gihapon, saan na ito pag-measure niya, saan pag-test. So, marang gihapon. Okay, so, kanimo na yung mga criteria to consider. So, what's the clinical significance of our GFR? So, again, di ba mo ito ang best overall indicator of the level of functionality of our kidneys. So, again, it determines also the number and functional capacity of our nephrons. Mga pilang ka-nephron, no? Ang kaya pa. Okay? So, for example, when half of the nephrons are non-functional, so your GFR will not change. Kaya nga naman, your functional nephrons will double their filtering capacity. So, muna nga, pwede na mag-kidney ka ng donor ba? Diba, ibaligyan nila ng kidney para magka-iPhone, no? Taon ko. So, kana, pwede rin mo i-donate mo isa ka kidney, niya mabuhay naman ka. Kira man kay, nga no, ang imuhang pikas kidney, mo double siya siyang effort. Luwi sa siya. So, kasi mas dali noon na siya madaot, no? Pero noon, kaya pa imong GFR. Okay, and then, your GFR also determines the extent of the nephron damage. in cases of renal diseases. And it also monitors the effectiveness of the treatment para mas baon naton sa ano to pag prevent further damage of our nephrons. And also it determines the feasibility of administering medications. So it tells us if okay ba, kaya ba, maayo ba nga administer nga medication kay basin kani nga medication kay makadaot tayo sa kidney. So makita po na sa GFR nato, di ba? There are certain medications that can affect the functionality or the kidney. It can damage our kidneys. Okay? So kana. So as what I've mentioned ninyo ganina, your urea clearance wala na siya ginagamit karon. Although this is the earliest glomerular filtration tests. Okay? Kinaman siya sa urine. Naman jud siya sa urine so unsaon nimo. Okay? And ang method to measure your urea kay naaman sad. Okay? But wala na siya ginagamit karon because 40% of your filtered urea is reabsorbed man balik sa imong body. No, so 60% na lang naa sa kuan sa to gani urine. So dili nimo ma-measure accurately the total amount of the urea nga gi-filter kay reabsorb man siya. Kaya di ba usa sa katong criteria for to ensure nga atong glomerular filtration test kay accurate kaya dapat neither reabsorbed nor secreted by the tubules. So wala kapasal sa urea ana. Okay? Kana siya. So inulin clearance. Inulin clearance, your inulin is a polymer of fructose. So gina-intake ni siya sa pasyente, di ni siya makita sa lawas. Kinahanglan pa ni siya i-intake sa pasyente. So it is an exogenous material taken by the patient. So stable kay siya, nakapasar siya nga criteria. Stable siya, dili siya ma-reabsorb, dili siya ma-secrete, of course, immune pa man mo siya. But kinahanglan pa siya intravenously infused. So mag-IV pa na sa patient. Dapat constant ang rate throughout the testing period. So kwan siya, invasive siya. So mo ni ang original reference method for clearance test, your inulin kay stable, nor neither reabsorbed nor secreted, pero dili lang siya normal body constituent, and then kinahanglan pa siya i-infuse via IV. This invasive siya. Okay? So karon ang common karon is your creatinine clearance. So creatinine is normally found at a relatively constant level in the blood. Okay? And then kita ra siya sa lawas. Okay? Endogenous siya nga procedure. Dili kinahanglan ma-intake ang pasyente ani. Okay? But ang problem lang is some creatinine is secreted by the tubules. Okay? And also there are some chromogens that are present in the plasma may react during chemical analysis. So na yung mga interferences also. And also if bacteria, present si bacteria in napasagdan ng imong nga sample din ha, bacteria will break down urinary creatinine if specimens are kept or stored at room temperature. Siyempre, room temperature, daghan din yung bacteria. Nga si bacteria, iyahan mga yang i-breakdown si urinary creatinine. And also, if imuhang diet kay heavy meat, okay, so reflect po na sa imuhang creatinine clearance if we are using 24-hour urine specimen. Okay, na siya mga disadvantages po. Okay, so creatinine clearance, of course, sa una, 24-hour, nakasuway ko, 24-hour urine, ng botilya gali sa kanang 1.5 nga kuan, soft drinks, mo ni sudlan sa ihi, no? Yeah. Kanang ibutang mo na sa ref sa laboratory niya. If manghihi na pasyente, kwaon na sa SO dadto. Na sudlan, and then balik na po sa lab, ano siya. So, hasul siya kay 24 hours ago. Pero karon na yung mga newer collection method nga dili kaya nag 24-hour urine. So natay serum creatinine, natay cystatin C and beta 2 microglobulin values. Okay? So but measurement of your creatinine clearance is not that reliable indicator, especially if ang patient kana siya ay muscle wasting disease. Kaya your creatinine is a breakdown product of your creatine. Creatine is an enzyme found on your muscles. See? Na kay muscle wasting disease, of course, lies man ay imong mga muscle cells, magawas imong creatine, of course, ma-convert to creatinine, so dili siya accurate. Okay? So also if we are doing 24-hour urine collection, accurate results depend on the accuracy and the completeness of that collection. So dapat yung mga mausik, yung mga masayop, ano ba? So dapat also ma-correct po ang body surface area. Okay? And especially if kanang daot ba kayo siya or dako ba siya, wala siya sa katong normal body surface, baka 1.73 meters per second. So dapat ma-correct po ang body surface area if mag-calculate na. Especially if children, gamay pa man, so calculate po na siya. Okay? So, the greatest source of error if we are doing creatinine clearance or if we are doing the 24-hour urine creatinine clearance is improperly timed urine specimens. Okay? So, okay. So, sayop ang pagka time sa ato ang specimen collection. So, for example, 24-hour urine specimen, creatinine clearance, 24-hour urine, kay, sample mag 24 hours man. So, for example, sugod ka alas 7 sa buntag, maman pod ka alas 7 sa buntag, sulod nga adlaw. But, ang pag-collect ka na niya, inig alas 7 sa buntag, kayon ka, mangihi ka. Dili pa na nimo isulod. So, nag-start ng time. Dili pa nimo isulod, ang kanang urine nga imong giihi pag alas 7 sa buntag, na-form man na siya before 7 a.m. So, i-void na siya. Ito na sa sink naman. Sa bowl sa CR. Then, after ana, katong mga ma-form within 7 a.m. pa nung 7 a.m. next day, mo na yung isulod. And also, ikabot sa 7 a.m. ugma, kay, for example, 7 a.m. kunya, tag-ani, kanang, wala pa kakaihi. Nga, pag abot sa, or pag 7 a.m. kay na, kuha na ka, kanang na, kayon ka, so imong gyapon na i-appeal. Or nagiuban nga sa 7 AM na, pero pas la kaihi nya pag 7:30 kayon sila, ilagya po na isulod kay ang kanang ihi is na form na siya before 7 AM. Inana siya. But ang uban, maglibog sila sa timing. So mo na ang greatest source of error for creatinine clearance, improperly timed during specimens. Mas malimot ana siya. Okay? So, how do we calculate our GFR? Okay? So, for this Friday, I think wala appeal sa quiz. Okay? Ang calculation of GFR. But ano lang yung summative, so still study. So, how do we calculate our GFR? So, it is reported in milliliters per minute. So, muna yung unit of measurement niya, ml per minute. And what are the data nga ito ang ginid? First is we have to have the urine volume. Then, the concentration of our urine creatinine and the concentration of our plasma creatinine. So, urine volume, so ano yung pagkuha sa urine volume? Imura ba na ipasa sa ihi? Kaya mo ba nang tanawon asa dapit ang katong mark? No. So, what you will do is, yes, you look at the amount of the urine nga gihatag sa imuha. You convert it to ml. So, for example, usa ka litro, pila man na ka ml? 1,000. Okay? So, in order for you to get the urine volume, you have to divide the ml, okay, the urine volume in ml by the number of minutes nga gi-collect siya. For example, agayon niya naatay ka na, example. Then also, we have to have the concentration of urine creatinine, so in milligrams per dl, and then plasma creatinine milligrams per dl. Okay? So, kanang example. Una is, how do we calculate our urine volume? So, sa gitong urine volume, yung unit, ml per minute. So, kung ano itong urine volume gipasa, butandrio, na ay 2-hour specimen measuring 240 ml. So, how do we calculate our urine volume? So, of course, di ba, ang volume is ml per minute. So, dapat, i-convert na to ml per minute. Kani kay 2 hours man. So, pila man ka minutes ang 2 hours? 120 minutes. Ada. Then, pila man ka ml ang 240 ml? 240. Dala, 240 ml naman siya. So, in order for us to get the volume, so, ml divided by minutes, so, 240 ml divided by 120 minutes, so, naatay urine volume of 2 ml per minute. Okay? So, mana siya. 2 ml per minute. So, atong kuwang na lang is concentration of urine creatinine and concentration of plasma creatinine. So, kanin. This is the standard formula to calculate, okay, the milliliters of plasma cleared per minute. So, kaning concentration. So, the amount that is cleared per minute. Mo na yung formula. So U is the urine creatinine concentration, V is the volume of urine, and then P is the plasma concentration of your creatinine. And then if you want to adjust the clearance for the body size, mo po niyang formula. So the formula, your clearance times katong body surface 1.73 and the age manguro ni. Okay, especially if bata yung mga pasyente. Okay. So kanina ay example. For example, you have a urine creatinine concentration of 120 milligrams per dl, a plasma creatinine concentration of 1 milligrams per dl, and a urine volume of 1,440 ml obtained from a 24-hour specimen. Calculate the GFR. First, you calculate the V. Okay? So, pila ka ml? Again, V is ml per minute. Okay? So, 140 ml and then 24 hours man. Pila man ka minutes ang 24 hours. So, 60 minutes times 24 hours, 1,440 minutes. So, your volume of urine is 1 ml per minute. And then you calculate the clearance. So, C is equals to UV over P. Diba? So, your U, 120. And then your V, 1 minute, 1 ml per minute. And then your P, 1 milligrams per dl. So, yun mo nang ikuan, 120 times 1 divide 1, 120 ml per deciliter. So, this is your clearance. Okay? So, kana siya. Sino kayo? Sino kayo? Okay? So, estimated GFR. So, karon ginagamit po ang estimated nga GFR. So, this is the most frequently used formula, the modification of diet in renal disease or your MDRD study. Modification of diet in renal disease study. So, mo niya frequently used formula if you want to get the estimated GFR. And this is the formula recommended by your National Kidney Disease Education Program, your NKDEP. Okay? The formula recommended can IDMS. Okay? MDRD IDMS traceable formula. And but the reference method for estimated GFR is your IDMS, isotope dilution mass spectrum. So, mo na nga imuhang National Kidney Disease ang recommended lang ang formula is the combination of your most frequently and your reference method, which is MDRD IDMS. So, if ang question gali, most frequently used formula for estimated GFR, MDRD. Reference method, IDMS. Formula recommended by your National Kidney Disease Education Program, MDRD IDMS. Okay? Okay, next, cystatin C. So, karon, usa ni sa mga commonly ginagamit na nga substances for clearance test. So, this is a small protein, a molecular weight, having a molecular weight of 13,359 produced at a concentrate by all nucleated cells. Panang cells nga na nucleus, produce og cystatin C. It is readily filtered by the glomerulus and it is reabsorbed and broken down by the renal tubular cells. So, mo po niya nga disadvantage. But the serum concentration can be directly related to the GFR. Okay, so nice ni siya. So, dugo ang gamit ani ha, dili. So, serum concentration can directly be related to the GFR. And nindot ni siya for pediatric patients, mga bata, na diabetes, elderly, and critically ill patients. Okay, so lisod man ni sila kuhaan ng 24-hour urine, di ba? So, yeah, for diabetes po sila ihi, kuha nga na ng 1.5 liters. Okay? Anak niya, tiguang palis, so na sila critically ill. And also, your cystatin C is independent of muscle mass. So, pwede, pag high in meat diet ka, or nakay muscle wasting disease, okay ra ang cystatin C. What about your beta-2 microglobulin? So, your beta-2 microglobulin, it dissociates from your human leukocyte antigens, or your HLAs, at a concentrate. And it is rapidly removed from the plasma by your glomerular filtration. And the rise of the level of your beta-2 microglobulin in the plasma is more sensitive indicator of a decrease in GFR than creatinine clearance. Okay? So, mas sensitive siya. So, mas ang pag-rise niya sa iyang level in the plasma is sensitive indicator. So, mas una siya, dali siya musaka. if ever na ay decrease in GFR compared to creatinine clearance. But if ang pasyente kay na immunologic disorder or malignancy, of course, false ang mga results niya mahatag. Hindi siya reliable. Kaya again, asa siya? Dissociates from human leukocyte antigen. So, immunologic disorders, okay, immune good. So, nandiyan involved ng mga WBCs and all, malignancy, mga cancers and all. Okay? So, also, there are studies, recent studies nga, nag-show that if we measure both serum and plasma cystatin C and creatinine, mas maka-provide siya of more accurate information on a patient's GFR. That is for cystatin C. Di mo, bitat to naman din. So, cystatin C, if atong diba, ingon diri nga, nindot man sa cystatin C, diba, yung serum concentration can be directly related to GFR. But then, if atos yung i-combine with creatinine clearance, kay mas, mas makakuha og accurate information regarding sa patient GFR gyud. Okay? Nya kani beto microglobulin bati lang siya if na ay immunologic disorders or malignancy ang patient. Okay, radionuclides, these are exogenous procedure. Parehas na sa inulin, exogenous po. But the use of radionuclides is more labor intensive and costly. So what happens here is that your radioisotope or radionuclides such as your 125 iothalamate provides a method to determine your GFR through the plasma disappearance of the radioactive materials. So, ang tabuan ni the rate of the disappearance of these radionuclides in the plasma correlates with the GFR of your patient. Okay? So, kani gamit ni siya to measure the viability of a transplanted kidney. So, this a picture na to, makita na to. Okay? Kaning na ay nag-graph diri. So, kita ninyo, if the kidneys, ang katong gitransplant na kidney is viable ba? Nahimo ba niya iyahanga ang function? Okay? Kay ang gina-measure aning radionuclide is the disappearance man of the radioactive material. If ma-filter ba sa kidney, especially if katong kidney is transplanted ba, if na-perform ba sa kaning transplanted kidney iyahanga function, na-clear ba niya kaning radioactive material. Okay? So, makita nyo diri nga, as time goes by, nagkawala. Okay? Yan, nagka-intensify pod ang color diri sa imong my bladder, meaning, natapok yun diri imuhang radioactive material. Okay? So, kana siya. Okay, tubular reabsorption. For tubular absorption, of course, it involves your PCT, your DCT, okay? So, di ba, ganina, ingon ko ninyo, aside from your, ganina nga, glomerular basement membrane, it also, if makalusot siya using active and passive transport. So, also in the reabsorption mechanisms, active and passive transports are also ginagamit po siya din because not all substances can directly or kanang sayon-sayon na siya og lusot dili. Okay, so there are some substances that in order to be reabsorbed, it must be combined with a carrier protein, and there are also substances that they can move. These molecules can move across membranes because of the difference of their concentration or the electrical potential on each side of the membrane. So, later, I hope mag-explain ako taro. Sige. Okay, so, kani is a table where you can see different substances and then asa sila gina-reabsorb. And if actively reabsorb or passively. Again, active, the use of transport protein. Passively, no need of transport protein. The movement of the molecules can be due to the differing concentrations on each side or the differing electrical charges on each side. Okay, so active, in your PCT, your glucose, amino acid, salts, and sodium are actively reabsorbed. On your ascending loop of Henle, your chloride is actively reabsorbed. And your And your sodium in DCT is also actively reabsorbed. Okay? And also, it's in your passive, in your PCT, your water and urea is passively reabsorbed. In descending, water is passively. Ascending, urea and sodium is passively. And collecting ducts, passively. So if you can observe here on your on our table, kung makita ninyo awa ang water. The water is passively reabsorbed on your PCT, DCT, and collecting ducts. So later may bawa nato ngano wala lagi siya sa ascending loop, miss. Okay, o sa DCT, miss. Hopefully testing tarong. Sige lang. Okay, and also here in your ascending loop of Henle tanawa, ang ma-reabsorb lang are your sodium, fluoride, and urea. Pero wala si water. So mahiwa niyo na later. So countercurrent mechanism will enter. Okay? So kana. Okay, terms as we go through, okay, our tubular reabsorption. So first is we have the maximal reabsorptive capacity. So this is when the plasma concentration of a substance that is normally completed niabot sa abnormally high level and the substance begins appearing in the urine. Okay? So again, so naisa ka substance normally completely gid siya gi-reabsorb, wala gid kay makita sa urine. Okay? But then tungod kinaabot man siya taas kay nga level, the substance begins appearing in the urine. So meaning naabot na sa maximal reabsorptive capacity mong kidneys. And renal threshold, on the other hand, this is the plasma concentration at which the active transport stops. Again, renal threshold meaning the plasma concentration of a certain substance naabot na niya na at which the active transport stops. Okay? So, ang mga actively transported nga mga substances mo ay maapektuhan ani. For example, is your glucose, di ba? Your glucose is actively transported in your PCT. If maabot na siya ani nga particular concentration, mo stop na ang active transport para ma-reabsorb ang glucose. So, ang mahitabo is pagawas na siya. Okay? So, mo na siya. And then, please note, your glucose that appears in the urine of a person but na siya normal blood glucose level is the result of tubular damage and not of diabetes mellitus. So, say, makaingon ta ba? Ala, positive yung glucose, nani siya diabetes. Not necessarily all the time. Tingnan naman. For example, if the patient, yes, positive iyang glucose sa urine, but then normal iyang blood glucose level, meaning damage iyang tubular, iyang tubules. Kaya naman, wala na reabsorb balik. Okay? If diabetes mellitus, both in the plasma and the urine, you will see, in the plasma, you will see an increased concentration of plasma glucose, blood glucose, and in the urine, of course, kita kag positive glucose test. But if the person has normal blood glucose, normal blood glucose level, kita ka og positive glucose test sa urine, meaning na tubular damage. Okay? Mana siya. Okay, tubular concentration on the other hand, renal reabsorption. Tubular concentration, one of the function of our nephrons, diba? Especially your medullary, okay, your juxtamedullary nephrons is to concentrate our urine. So where does the renal concentration begin? So it begins in the descending and ascending lobes of Henle. So ato yung gingon ganina, kung bantayan ninyo, ang water is passively rigid siya gina-reabsorb, and then dili ka kakita nga gi-reabsorb si water sa ascending lobe of Henle and distal. Okay? So kanang iba na to na karon. So renal concentration, pag concentrate sa mong urine, magsugod siya sa descending and the ascending lobes of Henle. Dira magsugod. So there is a term called countercurrent mechanism, which is a selective reabsorption process. Okay? Which is a selective reabsorption process that serves to maintain the osmotic gradient of the medulla, which is essential for the final concentration of the filtrate when it reaches the collecting duct. So, may tabuan na is Ang ato ang medalla, okay? Our medalla naa siya gina-maintain nga osmotic gradient. Okay? So naa siya gina-maintain nga osmotic gradient, which is very important for the final concentration of the filtrate kung maabot na sa collecting ducts. So dapat ma-maintain yun na siya. So countercurrent mechanism, okay? So it is a selective reabsorption process para ma-maintain na siya nga osmotic gradient sa ato nga medalla. Okay? So what will happen di ay? Okay? So so what will happen is the water, di ba? Kung mabalik ta diri sa table, di ba? Na table diri. So, di ba makita niyo din hinga on our PCT, proximal convoluted tubule, na atay reabsorption of sodium, tapay other salts, di ba? And 2/3 of the filtered sodium mahitabo man diri sa PCT. Okay, 1/3 na diri. I mean, magtunga pa ni sila diri. Ascending o DCT. So 2/3 of the reabsorbed sodium mahitabo sa PCT. And the amount of sodium that is reabsorbed in the PCT is accompanied by the equal amount of water nga i-reabsorb po. Okay, so unsang amount sa salt or sa sodium nga gi-reabsorb sa PCT, that is also the amount of water nga gi-reabsorb passively sa imong PCT. Okay? And also, it continues on your descending loop of Henle. But on your ascending, wala na kayo makita ang water diri. Puros na lang salt. Then DCT pod, sodium na lang. Diri na siya nibalik sa collecting ducts. So what will happen, what happens is that diri ni sulod si countercurrent mechanism. Because again, as what I've mentioned, our renal medulla na siya gina-maintain nga osmotic gradient. Okay? So dili pwede nga pataka lang or patuyang lang og reabsorb og water si kidneys or si nephron. Okay? Kay maapektuhan man ang kini nga osmotic gradient. And this osmotic gradient is essential para ma-concentrate ang final filtrate dito sa collecting duct para mahimo ng urine. Okay? So makuha na nato later. So di ba, makita niyo diri sa picture. Kita niyo diri awa. Ang osmolality sa filtrate is 300. Okay, pag-abot sa PCT, okay, 300 gihapon siya. And then pag-abot sa diri sa descending loop of Henle. So diri sa proximal nigawas na si water, nahinay siya gawas. Diri sa descending nigawas pud siya. And if atong panon, di ba, the only thing nga gi-absorb sa descending is water. Okay? Water gyud, awa. Water gyud siya. Okay? So nagkagamay si water, di ba? 300 siya diri, kailangan pa magtubig diri. 300 siya diri, nga pag water, pag abot diri sa descending loop of Henle, kung makita ninyo, nagka-dako ang osmolality sa ultrafiltrate. Nahimo 600, nahimo 900. Pag abot diri sa tunga gyud sa loop of Henle, nahimo na siyang 1-2. Kaya ang water, nanggawas naman tanan. Kasi water dapat i-reabsorb man diri, pabalik sa blood vessels. Okay? Kasi sodium pod, i-reabsorb man diri si sodium pod. Di ba? So what will happen? Okay? So what will happen? Meaning aning kanang 1-2, meaning kanang wala kay siya ba kanang ispiso na kay siya ba? Nanggawas man ang tubig. And also, diri sa imong medalla ni sa may kanang kwan sa ispiso, kanang opposite, kanang lasaw. No, lasaw na kay dinhi. And it is very important nga makorek gyud na siya. Okay? So ang say mahitabo diri sa ascending na, pag ascend na balik dinhi sa filtrate, si sodium gawas na pod balik. Okay? Kaya para ma-reabsorb na pod siya. Okay? And then, but your water tanawa. Wala na ni gawas si water. Wala na kayo makita nga H2O diri dapita. Si water gi-preserve na. Di nakagawas si water. Pero imong sodium nang gawas. So, gikan sa pagkalasaw, since si sodium na lang man ang nigawas, nibalik na siya kay espiso. Ang water nimo gikan sa 1 to kaya wala man jud siya gipagawas, abot din naning gawas ng sodium, na-dilute na siya, nahimo na 100 ang osmolality. Kinang gawas, di man kagawas si water. This is to ensure nga dili mulasaw maayo ang medalla. If mulasaw maayo ang medalla, it will affect the final concentration of urine here in the collecting ducts. Okay? So pag-abot sa ascending, so puros na lang asin ang nanggawas. Si water wala kagawas. That's countercurrent mechanism. Descending loop of Henle, puros ra tubig. Okay, puros tubig, so na-dilute ang medalla. Okay? Para dili siya magpabilin nga diluted, pag-abot sa ascending loop of Henle, si sodium na ang gawas. Si water wala na kagawas. So nibalik og ka, lasaw ang filtrate. And then ang medalla nibalik siya sa iyang osmotic gradient, which is very important for the final concentration of urine. So niagi siya dinhi pag-abot na sa DCT, wala na siya kagawas. Pag-abot na diri dapit sa may collecting ducts, diri na nibalik og gawas si water. So dira na siya diri pod kuan pod diri sa collecting ducts. Okay? So this is important for the concentration of your urine. Okay? Kani collecting duct concentration. So kani this is where the final concentration of your urine happens, because diri the reabsorption of water again begins in the late diri na, di ba? Yun ako ganina, diri na siya sa may end dapit. Diri na siya mobalik nga mo reabsorb balik og water. Okay? Until mupadayon siya diri sa collecting ducts. Okay? So kani siya, the concentration of your ultrafiltrate will depend on the osmotic gradient in the medulla and also by the hormone ADH. Okay? So if for example ang imong medulla, okay, wala niya na maintain, okay, ang imong if wala niya na maintain ang imong osmotic gradient, no, sa medulla. For example, kato diluted kayo, diluted ra gyud siya. So dili niya ma-concentrate, yung maglisod og concentrate ang collecting ducts sa urine nga iyang ipagawas. Kaya nga naman, if for example si water mugawas gihapon siya diri sa ascending loop of Henle ug diri sa imong DCT mugawas gihapon siya. So grabe na kay ka-diluted diri. Okay? Yeah, for example, ang sulod kay grabe na gyud ka ispiso, no? So igabot na dinhi sa collecting ducts, halos wala na mabilin nga tubig. Unsa may ipagawas na to? Unsa man nato pagpagawas sa mga asin, sa mga pagkaon ng mga asukal, no? Kanang mga substances, mga waste nga dapat ito ipagawas. Okay? Dili na nato mapagawas if wala ni tubig. Okay? So importante gid siya nga diri siya sa descending early mugawas. But pag-abot na sa ascending padung sa may end sa imong distal, dili na makagawas ng tubig din ha. Okay? Kaya para ma-maintain ang osmotic gradient, para abot diri sa collecting ducts, ma-concentrate og tarong ang urine. Okay? Okay, para if ever need pa gyud mag-reabsorb og water diri, kaya para ma-concentrate ang urine, makagawas pa si water. Okay, kung puros na lang water nang gawas dinhi, unsa pa man water ang gawas diri? Wala na. Okay? And also, your ADH, if your ADH will act on your collecting ducts. Ano say trabaho sa ADH? Iyahang i-stimulate si collecting duct nga mo reabsorb og water. Unsaon pag reabsorb og water kung nahurot na tanan diri? So wala gihapoy pulos. Okay? So importante na siya. Also your ADH, it determines, or the production of your ADH is determined by the state of your body hydration. So depende na sa tubig na naa sa imuhang lawas. Okay? Pindi na sa tubig na sa imuhang lawas. So, the state of the hydration you have in your body. So, for example, kompleto ka sa tubig, saktong tubig nimo, 2 liters per day. Wow. Okay? 8 glasses per day. Sakto yung body hydration. The level of your ADH is low. Okay? Meaning, sakto naman ka sa tubig. So, no need for the body to reabsorb, to signal your collecting ducts. Collecting ducts, uhaw na kayong lawas. Pag magluoy na kayong lawas, pag reabsorb balik ng tubig. So, wala na. Okay, so if sakto rin mong body hydration or daghan kag inom nga tubig, low rin mong ADH, so meaning daghan po imong urine volume. Okay, meaning ana, gamay rin mong ADH. So gamay raman ang water nga i-reabsorb pabalik sa lawas. So ang mitabo, ang tubig pagawas ra. But for example, uhaw kay ka, kawa kayo inom tubig, init kaayo. So panimot pa ka, 'di ba? Gamay pa yung tubig nga giinom. So what will the body do? Of course, it will signal the hypothalamus, uy, hypothalamus, palihog ko paghimo og kanang ADHB niya, hatagiton mi dinhi. So mutaas si ADH level, and then it will act on your collecting ducts, and then your collecting ducts will, of course, himo niya iyang function. So iyang buhaton is si water, iyang i-reabsorb pabalik sa lawas. So kay ang tubig nibalik man sulod sa lawas, so what will happen to the urine volume? So mugamay. So mana kung tugnaw, di ba kabantay mo kung tugnaw kaayo? Kung tugnaw kay sige na tag-ihihi. Kaya wala man kayo tay water nga nanggawas sa atong lawas. But if kan init po kayo, mo tay ihihi pod, manghim ta gamay ra pod, no? Kana control na sa atong body. Okay? So kana tubular reabsorption tests. What are the tests to measure your tubular reabsorption? So the loss of tubular reabsorption is often, no, the first function affected if you have renal disease. Okay, so what are these tests in order for us to know if kaya pa ba sa itong tubules na reabsorb? We have concentration tests. So it determines the ability of the tubule to reabsorb the essential salts and water that have been non-selectively filtered by the glomerulus. So concentration, kaya pa ba sa itong tubules nga mo concentrate sa itong urine? And also, please take note, if we are making these concentration tests, the control of fluid intake must be incorporated in these lab tests. Okay, again, we are measuring the concentrating abilities. Dapat na atay base na value. Dili pwede bisa kung sila nun. Dapat controlled siya and also the volume. Para kabalot ta, sa ito i-measure at the end. Okay? So, sa una, historical note, Fishberg and Mosenthal concentration test mo ni ang ginagamit. So, ang buhaton sa Fishberg test, kay ang mga pasyente dili nila paimnon og bisag unsa, dili nila pinog tubig for 24 hours. Grabe no. So for 24 hours dili sila mo inom. Nya after 24 hours i-measure ang specific gravity silang ihi. So dira makita if nakaya ba sa imong kidney nga mo concentrate sa imong nga urine. So wala gud kay inom tubig. So ang tawag ani ang expected nga result, of course, dapat taas imong specific grav, diba? Kaya gaman kag tubig, puros na lang man ang mga analytes, sediments na din ha. On the other hand, Mosenthal test. So, ang himno ni Mosenthal, kaya i-compare ang volume and specific gravity sa buntag o sa gabi nga urine. So, dira iyang tan-awon, i-evaluate niya ang concentrating ability sa imong kidney sa buntag o sa gabi. Okay? And also, aside from Fishberg and Mosenthal test, there are currently concentration tests nga ginahimo karon is your specific gravity and your osmometry. Specific gravity, this is most useful as a screening procedure. Okay, so ma-obtain na to ang kining value is using our reagent strip. Osmometry, this is the best assessment for quantitative measurement of renal concentrating ability. If you want to measure the renal concentrating ability, yun mismo, we use the osmometry, although dili ka siya gina-perform. Specific grav screening na sa reagent strip. Okay? So, today pod, napod tay fluid deprivation gihapon of and urine and serum osmolality. Okay? So, ang buhaton nila is, after ni mo kaon panihapon, di na din ka mo intake of any fluid for 12 hours. So, dito ni siya kay ngano, after mo kaon, 12 hours ka, tulog na lang ka. Dili ra kayo maglisod ng pasyente kasi atong 24 hours nga kayo inom, grabe ka. So for 12 hours after dinner, 12 hours dili na kamo intake of any fluid, and then after ana kay kuha dayon og after 12 hours ngihi dayon ka. So if your urine osmolality is greater than or equal to 800 milliosmoles, normal, okay, normal. But if your urine osmolality is less than 800 milliosmoles, okay, may ra dili ka siya espiso. So dungagan og 2 hours ang imong fluid restriction. Then after 2 hours na pod, collect na pod og urine. If ang imuhang urine osmolality is mo greater na to 800 milliosmoles, normal. But if less than gihapon 800 milliosmoles, meaning basi na akay diabetes insipidus, so there should be further testing. So you say milliosmoles, meaning kung ispiso ba or dili ba imuha nga urine. So di man ka 12 hours gud ka inom. So dapat mo ispiso gyud imong urine. Mabita na nga if greater than or equal to 800 kay normal, but if less than kay need pa og further, di ba, nga fluid restriction. Pero if ever gani nga is diluted gihapon, bisan gid 14 hours na ka walay inom-inom ng tubig, so you are tested further for diabetes insipidus. Basin kuwang jud ka og ADH, no? Basin naa jud kay either naka-nephrogenic or neurogenic diabetes insipidus. Okay? So kana siya. So kani what happens is, for example, this is for the diabetes insipidus. Okay? So for diabetes insipidus, nas like polyuria, same sa diabetes mellitus. Sige sila og ihi. But the urine osmolality around is less than 200. Grabe ka diluted. And urine to serum ratio is 1:1. And then if they undergo to fluid restriction, less than 400 milliosmoles. So diluted gihapon siya. And when we perform ADH challenge, meaning mag-introduce ta og ADH. Okay? If mag-introduce ta og ADH, most likely kinani mo ni ang naong sa diabetes insipidus. Di sila ihi, but very diluted ilang ihi. So if we do ADH challenge, okay? We introduce ADH, and then if we get a result of our urine osmolality greater than 800 milliosmoles, meaning there is a decrease or there is a lacking or deficiency of the ADH level, meaning neurogenic diabetes, meaning the problem is the amount that is produced by your hypothalamus. Neurogenic, meaning the problem is here in the hypothalamus, meaning dili siya mag-produce of enough amount of ADH. If after ADH challenge kay na-correct imong osmolality, ni kuan na siya, ni ispiso na siya, greater than 800 na good. But if after ADH challenge kay less than 400 gihapon imong osmolality, so meaning na kay nephrogenic diabetes, meaning na kay ADH but the problem is diri sa imong kidneys. The problem is naa sa imong collecting ducts. Your collecting ducts does not respond, okay, to the ADH stimulation. Bisan pagdaghan kag ADH din ha. Pero kung imong kidney kay di siya mo respond, di siya mo kuan gyud. Mausik ra imong ADH. So diluted gyapon imong urine. Okay? Sinanay na pagkaibaw ha, the difference between nephro and neurogenic. So again, ganina nagkwantag mga concentration test karon. We have the specific gravity. This is the simplest test of renal concentrating ability. Okay? So it measures and is affected by the solute number and mass. So pila ka buok solute ug ang mass imo per solute. And please take note of this. If a certain specimen will fixate on a specific gravity of 1.01, meaning the kidneys has lost its concentrating ability, because 1.01 na specific gravity is the same specific gravity of the ultrafiltrate after it is filtered in a glomerulus. Okay? So ang specific grav sa imong plasma ultrafiltrate after sa ma-filter sa glomerulus 1.010 na siya. Okay? So kung maabot na ihi na nimo 1.010 gihapon, mura wala niagi og concentrating process ang wala yung concentrating ability. And the reference value for your specific grav is 1.005 to 1.030. If mo himo ginang 1.000, dili na ihi tubig na. Okay? And if mo saka siya 1.030, and if you are using refractometry, pwede mo saka o greater than 1.045 to 1.050 mo specific grav. But for your reagent strip, even if you are taking radiographic dyes, I mean, but if you are using the reagent strip, dili ra siya mo affect. Okay? Because of the principle that is used in determining your specific grav in your reagent strip. So the principle applies kay kuaman the polyelectrolyte ions. I think basta yan discuss na ni Ms. Dali. Okay, so mo na siya. Osmolality. Osmolality is affected only by the number of solutes. So a specific graph kay number of solutes plus its molecular weight, its mass. But osmolality only the number of solute. Okay, and this is more accurate, okay, than specific gravity when we assess renal tubular function, okay, or the concentrating ability of our kidneys. So what do we measure when we want to know the osmolality? We measure the colligative property of the sample. We use we determine the freezing point, vapor pressure, osmotic pressure, and boiling point. So reference value for the osmolality of our serum is around 275 to 295 milliosmoles per kilogram, and our 24-hour urine is around 300 to 900 milliosmoles per kilogram. So mo na siya. So for example, if naka-diabetes insipidus, less than 200, di ba? Unya if nag-fluid deprivation na less than 400 ra. So kita gyud ani mo. And reference standard for osmolality is the use of sodium chloride concentration. And mahibaw na nato later po during the introduction to the urinalysis. Okay? So clinical significance of the concentration test is it evaluates renal concentrating ability. It monitors the course of the renal disease. It monitors fluid and electrolyte therapy. It establishes also the differential diagnosis of hypernatremia and hyponatremia, and evaluates the secretion of and the renal response to ADH. And also, it may require determination of serum in addition to urine osmolarity. So, when we want to know the osmolarity of our urine, so makita nato dira if kaya pa ba sa atong kidney nga mo concentrate sa urine, base na natin sakit or kaning mga therapy nga atong gikuan naka-affect ba ni or successful ba niyon sa ba. Okay, so or our ADH in cases of diabetes insipidus. So, makita po na nato din. Okay, tubular concentration. Tubular concentration, here in the tubular concentration, it regulates the acid-base balance in the body through the secretion of hydrogen ions, and also it eliminates waste products not filtered by the glomerulus. Okay, so di ba ganina ingon ko ninyo nga around 120 ml is filtered by the glomerulus, but some of it nga dili ma-filter kay mo dito siya sa efferent arterioles, and then ato siya sa imong peritubular capillaries, and yung mahimo o vasa recta, then mo balik peritubular capillaries, di ba? So kana siya. Ang katong mga waste products nga wala na filter sa glomerulus niya na dala dito sa peritubular, vasa recta, peritubular. So if waste products siya, i-secrete gihapon siya and i-uptake siya dito sa imuhang tubular lumen. Okay? So the major site for removal of these non-filtered substances is the proximal convoluted tubulus. So, for example, there is imuhang di ba diri afferent arteriole imong dugo yan diri gi-filter ni 120. Uban nga wala filter anhi man na dinhi. So abot diri. Okay? Ang katong mga importante, glucose, sodium, salts, amino acids, i-reabsorb balik sa blood, di ba? Sa PCT. Katong mga waste products nga wala na filter diri, i-secrete diri para balik diri sa imong tubular lumen para mapagawa siya, ma-excrete siya. Okay? So mo na for tubular secretion. And also aside from that, it is to, di ba ingon diri, it regulates the acid-base balance in our body because it is our kidneys also is responsible for the secretion of hydrogen ions and the reabsorption of your bicarbonate. So kani acid-base balance, bicarbonate, your HCO3 negative. This is the major buffer of our body. So the blood depends on its buffering capacity. Okay, bicarbonate. Also your hydrogen ions, this is secreted by your renal tubular epithelial cells. Your RTEs, by the way, are the epithelial cells that lines your tubules. So your RTEs will secrete your hydrogen, and your hydrogen, because of the hydrogen secreted by your RTEs, okay, it prevents the filtered bicarbonate. Kaya ma-filter mo ng bicarbonate sa glomerulus. Nya, Ba after ma-filter sa glomerulus, agi man na sa PCT. Unya, imong PCT is lined by your RTEs. Your RTEs will secrete hydrogen. Pero katoy mong bicarbonate, dili ma-excrete sa urine. Kaya nga naman, di ba, bicarbonate and then hydrogen, bicarbonate plus hydrogen will form carbonic acid. Your carbonic acid is reabsorbed, processed by your anita din. Okay, so for example, kani, di ba, ingon diri nga, your RTEs, your renal tubular cells, epithelial cells, secretes hydrogen in order for your bicarbonate, in order to prevent the filtered bicarbonate from being excreted in the urine. Okay, and para ma-return ang bicarbonate sa plasma, kaya again, your bicarbonate is the major buffer of your body. Okay, so sample kanina, din sa 3.8, reabsorption of bicarbonate. So what will happen? This is your tubular lumen. Okay, and this is our peritubular plasma. Peritubular plasma, ini mo ni katong capillaries. Mo ni ang blood vessel capillaries. Kani mo ni ang lumen sa ato ang renal tubular cell. Okay? So si renal tubular cell, diba, siya ang mag-secrete siya og hydrogen diri pagawas sa lumen. Si bicarbonate gifilter baya siya sa imuhang glomerulus. Kung walay hydrogen, si bicarbonate mugawas na siya, ihira na nimo. Pero again, your bicarbonate usag siya, this is your major buffer in your body. Okay? Si bicarbonate kinahanglan nga mabalik sa dugo. So what will happen? Your RTE will secrete hydrogen. Your hydrogen will combine with bicarbonate, will form your carbonic acid. Okay? Will form carbonic acid, and then via the action of your carbonic anhydrase 4, your carbonic acid will be converted, or matunga siya, will be broken down into water and carbon dioxide. And of course, the carbon dioxide, yun na magawa sa urine. Okay? So again, bicarbonate is the major buffer in our body, in our blood. So, kung makita mo siya sa blood, ma-filter siya sa glomerulus. Dili mo siya pwede dapat mawala. Dapat i-recycle man siya. So, si RTA magpagawas og hydrogen. Si bicarbonate and hydrogen will combine, mahimong carbonic acid. And via the action of your carbonic anhydrase 4, this is an enzyme, your carbonic acid will be broken down into water and carbon dioxide. Water, of course, ato na sa kidney, ato na sa urine, and your carbon dioxide via the aquaporin 1 channel will be reabsorbed, or i-uptake siya sa imong RTE balik, ang imong carbon dioxide, and it will be combined with water. Okay? Your water and your carbon dioxide inside your RTE cell via the action of your carbonic anhydrase 2, ngayon mo siyang carbonic acid again. And your carbonic acid will be broken down into bicarbonate and hydrogen, and your bicarbonate will be reabsorbed back to the blood. Your hydrogen will be secreted back to the lumen para i-rescue ang katong mga na-filter uban pa nga mga carbonic acid. And aside from that, also some of the carbon dioxide will be will be transported back to the blood directly, and combine siya sa imuhang hemoglobin para ma-release po siya sa lungs. Okay? So, muna may tabo. Reabsorption of filtered bicarbonate. Okay? So, kana, for bicarbonate. And aside from bicarbonate, we also have other substances that are buffers of our blood. We also have our phosphate. Okay? So, same gihapon na may tabo. Diba? Your RTEs will secrete hydrogen back to the lumen, and then your hydrogen will combine with your phosphate, and it will form your your hydrogen will combine with phosphate, and then it will form your dihydrogen phosphate. So your dihydrogen phosphate, dili ni siya i-reabsorb balik. So ipagawas na siya. Okay? Pagawas na siya. Okay? For example, if if naatay in cases of in cases of metabolic in cases of metabolic nga acidosis. Okay? So, your hydrogen must be dapat sa hydrogen dili magpundog yun. Okay? So, dapat na ay more reabsorption of bicarbonate. Okay? And hydrogen must also be ma-excrete siya gawas sa lawas. So, your hydrogen also, for example, if na ay metabolic acidosis, there should be a more reabsorption of your bicarbonate and more excretion of your hydrogen. So what happens is some of the excess hydrogen will be combined with your phosphate, and then it will form your dihydrogen phosphate, and then it will be excreted in the urine. Also, that is also true with your when your hydrogen is combined with your ammonia to form ammonium to be released or to be excreted in the urine. Okay? So kani just study the picture. Number din sa inyo ha Stressinger. Okay? But the common or the vital reabsorption of bicarbonate to maintain the acid balance in our blood is kato akong explain ganina. Okay? Okay, so any disruption in these secretory functions can result in metabolic acidosis or renal tubular acidosis. Meaning anak dili ka produce og acid urine ang patient. Okay? So kay di ba mahimo man siya o if metabolic acidosis kay naay less reabsorption of your bicarbonate. Your bicarbonates are excreted in the urine. So meaning there is less also hydrogen secreted by your RTEs. Okay? So ang may tabo, walay mo combine ni bicarbonates, si bicarbonate mo gawa sa ihi. Walay bicarbonate nga ma-reabsorb balik sa blood. So magka-acidic ang ato nga dugo. So, disruption of the secretory functions can result to metabolic acidosis or your renal tubular acidosis. Meaning inability to produce acid urine. Okay, kaya nanggawa si bicarbonate. So what are the tests for tubular secretion and renal blood flow? So this test tests the ability of the kidney to produce an acid urine. So this depends on the secretion of your hydrogen ions by the RTEs in your PCT, and also the production and secretion of ammonia by the cells of your DCT. Okay, so for example, if kanang a normal person each day the acid about 70 milliequivalents per day of acid in the form of titratable acid or titratable hydrogen or hydrogen phosphate ions or ammonium ions, imo na iyang ma-excrete every day. So kung normal na siya, wala siya problema. Okay, so mo gyud ni ang titratable acid nga ihang ma-excrete either titratable hydrogen, your dihydrogen phosphate ions, or your ammonium ions na siya. But if na kay metabolic acidosis kay you'll not be able to form this. Instead, your bicarbonates are the ones released in your urine, and there's not enough hydrogen to combine to phosphates and ammonia para maka-form aning titratable nga mga acids. Okay? So, also, the diurnal variation in urine acidity or alkaline tides, other term, is shortly may tabo siya after mo bangon ka igbuntag. Okay? So, bangon yun sa buntag, mostly ang imuha nga pH of your urine is alkaline. Ito siya alkaline tides. And also, postprandially, okay, and at approximately 2 p.m. and 8 p.m. napod kay mga alkaline tides. Postprandial meaning after mo kaon. Okay? Especially imong gikaon kay mga vegetables, healthy living, alkaline na imong ihi. And the lowest pH di ay is found at night. Okay? So sa gabi na lowest pH. Grabe ka acidic yung mga pH. Okay? So, titratable acidity and urinary ammonia, these are the tests that we perform. So, aside from urine pH, makuha na nato using our reagent strip. We also do titratable acidity, measure if na atong hydrogen ions, the hydrogen phosphate and ammonium. Okay? Urinary ammonia, no? it can be used to determine if our tubules is already defective. It's not able to maintain acid-base balance by not reabsorbing our bicarbonates well. Okay? So what happens here is the patient is allowed to intake an acid load. It is an oral ammonium chloride. So inon na sa pasyente, and then the specimen that is collected from the patient is a fresh or toluene preserved urine at 2 hours interval. Okay? So ang gina-measure ani is either it titrates the free hydrogen or it titrates the total acidity of the specimen, and it also calculate ammonium concentration. Pero makita gyud is if the tubules or the kidney is able gyud to to maintain its function to maintain acid-base balance by reabsorbing bicarbonate and then secreting these acids like your free hydrogen, the ammonium, and even your dihydrogen phosphate. Okay, so the ammonium concentration is calculated via the total acidity minus the treatable acidity, so that could be your ammonium. Kaya imuhang phosphate or gamay ra siya o amount. Okay, so mostly mo na siya metabol. So wala kayo ginagamit si dihydrogen phosphate. So more on total acidity, then minus the free hydrogen or titratable acidity, and if calculated mo na ang amount sa imong ammonium concentration. Okay? So excretion tests, so we have para-aminohipurate test and your phenolsulfonphthalate dye test. Your para-aminohipurate test or your diode trust test, it measures your renal plasma flow, okay? And of course, na dye, your para-aminohipurate, so that's the dye. So it requires the clearance of that dye. And the reference value should be 600 to 700 ml per minute ang ma-excrete nimo. And then phenolsulfonphthalate dye test, it measures the excretion of dye gihapon, phenolsulfonphthalate dye. The amount or the measure of the excreted dye is proportional to the renal tubular mass. Okay? And the dose of your PSP is administered intravenously, so 6 milligrams. And then reference value is 1,200 ml blood flow per minute. Okay? So, kaning PAH or diode trust test, is measure of renal plasma flow, and I think phenolsulfonphthalate is your total renal blood flow. Okay, so you can also see the reference value. Diode is 600 to 700, which is the amount or the value of your renal plasma flow, while 1,2 is the total renal blood flow. Okay, so many ang mga excretion tests. So that ends our discussion for the renal function and tests, and I hope nga somehow na learn mo or kanang na understanding you. If ever you have some questions or naglibog mo, you can repeat or ikuha na ninyo, ibalik lang ang tanaw, or you can ask me para if naim maglibog or unsa ba kay or basin ay sayop, we can correct it. Okay, so that is for the renal function and tests. Thank you. God bless.